Today I am coming with a new topic. Why do electric scooters catch fire? Whether electric vehicles are safe? Are imported batteries compromising on quality? Whether India needs stringent norms for the electric vehicle sector? Whether the EV ecosystem without proper research and development and re-engineering are leaving safety loopholes? I am Kochu Baby Manuran and you are watching SKBM Videos Environmental Series Episode 22. With a sequence of recent electric scooter fire incidents in India, there is a growing debate and discussion about the safety of mushrooming electric vehicle brands, and the spotlight comes especially on their safety on Indian roads. In most of the cases, the electric scooters seem to have spontaneously erupted thick smoke and then fire. No doubt, these repeated fire incidents will affect consumer sentiments towards electric vehicles. These fires also have put a question mark on the role and efficacy of our regulatory bodies. Electric vehicle experts are of the opinion that 99% of battery fires are caused due to short circuits, which lead to the battery cell's temperature rising, leading to what is called a thermal runaway. Thermal runaway is the rapid and extreme rise in temperature in a cell of the battery. When cells heat up and initiates the same reaction in adjacent cells, it is known as thermal runaway propagation, which ultimately leads to smoke, fire, and even explosions. Short circuits can happen from poor cell quality, poor physical design of the battery, and a poor battery management system or BMS. Battery management system is basically an electronic system that is connected to all the cells in a lithium ion battery pack, which constantly measure their voltage and the current flowing through it. BMS is also equipped with a myriad of temperature sensors providing information on temperatures at different sections of the battery pack. The two most prevalent types of battery chemistry are the lithium nickel manganese cobalt oxide and lithium iron phosphate. Both have their pros and cons. Lithium nickel manganese cobalt oxide is a more advanced chemistry capable of delivering higher currents with higher energy density, but it is also more sensitive to temperature. With no cobalt, lithium iron phosphate has low toxicity, offers a longer life cycle, and is more stable but low on energy density. All batteries work best when they are at room temperature, but while charging and discharging, temperature is bound to go up. Lithium ion batteries are prone to overheating and needs a proper thermal management process. Sadly, not enough attention is paid to this by the industry. The most prevalent and cost-effective one is air cooling using thermal pads where air is blown over the surface to remove heat. All electric scooters in India are currently air cooled. A lithium ion battery is made of hundreds of lithium ion cells, and a deformity in even one cell could trigger an unstoppable chain reaction engulfing all the other cells. Each cell has its own recommended operating temperature by the manufacturer, and it is usually around 25 to 35 degrees centigrade. We need to ensure that the cells operate within this temperature range as much as possible. In the case of lithium iron phosphate, the battery will start to become vulnerable at 80 degrees centigrade, while in the case of nickel manganese cobalt oxide, even 65 degrees could be dangerous. Most players have simply imported battery packs from outside and not invested in thermal management systems at all. This is a dangerous practice. One of the potential solutions could be liquid cooling, where individual lithium ion cells are either immersed in flowing liquid or cooled indirectly by the liquid that flows through channels wrapped around the cell. Liquid has the capacity to remove heat about 1000 times better than the same volume of air. It is, however, relatively expensive and drains power from the battery itself because of the need to pump the coolant around the battery. A number of factors like variable temperature, terrain, stress, and abuse on vehicles makes India different from other parts of the world. But we need to ensure that the vehicle stays right even in such stressful situations. India wants electric scooters and motorbikes to make up 80% of the total two-wheeler sales by 2030 from about 2% today. Government is offering companies much incentives to locally manufacture electric vehicles. This electric mobility push is highly needed for our climate change and carbon reduction goals. How the situation is tackled will determine how consumer faith and confidence is maintained. Unfortunately, most companies are trying to shift the blame on poor charging practices by consumers and the rise in ambient temperature for the fire instead of finding the real root cause behind. Technology has the answers if we are willing to look for it. It is a myth that summer heat is causing this. This is also an opportunity for companies to prove their mettle and engineering excellence to come with a world-class product. It is desirable to note that Government of India has deputed an independent team to probe the incidents and to submit a report. But truth should not go under the carpet. If we really wish a real electric vehicle regime free from emissions and pollution. With this, I am leaving you. Do you find this video informative? If your answer is yes, please like, share and subscribe. Your support is really meaningful to me. Thanks a lot and see you next time with a new topic. A big thank you.